Hello student, this is El-Refaei, math teacher for both AS and A2 level. Today we're going to solve logarithmic equations. But before that, I hope that you revise the logarithmic rules that we learned in the previous classes. Now today we're going to solve logarithmic equations, but before that we're going to solve question number 1. Show me your calculators and let's find the answer for question number 1, parts I, double I, triple I, IV, and V. Let's start with I, log, base. 2, the value is 3. What is the answer? It's 1.58, approximately 1.58. Double I, 0. And this is a rule we learned that log 1 to the base A equals 0. Continue. Equals, oh, it's a negative 0.421. Math error. The last one. Also math error. According to that, log x more than 1 to the base A, I will have a positive answer. Log x equals 1 to the base A, it's a rule, 0. Log x less than 1, but more than a 0, between 0 and 1. X more than a 0, less than a 1 to the base A, my answer would be negative. And log x less than or equal 0 to the base A will be math error. Please, students, so I have to be careful that log always hold a number is greater than a 0 in order not to get math error. Excellent. Let's move to solve logarithmic equations. And I said before, please revise logarithmic rules before solving question number 2. Now, question number 2, part A. Log x plus 5 to the base 10 equals 2 plus log x to the base 10. As you see, the left side have one term, the right side having two terms. Now I have to combine the two logs and write one log term. So I'm going to move log x to the base 10 to the left side. Log x minus 5 plus 5 minus log x, both of them sharing the same base, equals 2. Why they should have the same base? In order to combine them. The combination for subtraction will give me division. So log x plus 5 over x to the base 10 equals 2. I'm going to convert it to the exponential term. x plus 5 over x equals 10 squared, which is 100. X plus 5 over x equals 100. Cross multiplication, or multiply both sides by x. X plus 5 equals 100. X minus x minus x. So 5 equals 99x. X equals 5 over 99. After that, you have to do check. You have to do check. Okay? Check where? By using the original equation. Let's check. Mhm. 5 over 99 plus 5 equals 0.703 to three significant figures. Let's see. The left side will be equal to the right side. 2 plus as we said, 5 over 99. The answer will be the same, 0.703. So this is the answer. Let's solve another one. Okay, as we said before, to combine two logarithmic terms, I have to check that they both having the same base and same coefficients. Do they share the same coefficients? No. I'm going to move 2 to become a power. So it will be log 2x, all of it, to the power 2 base 4 minus log 5x minus 6 to the base 4 equals 1. I have always to check before combining logarithmic terms. All the terms should share the same base and the same coefficient. Now, because they're sharing the same base and the same coefficients, and the relationship is division, the combining for division, the combining for subtraction is division. So it will be 4x squared over 5x minus 6 to the base 4 equals 1. Converted to the exponential form, 4x squared over 5x minus 6 equals 4 to the power 1. 4x squared over 5x minus 6 equals 4. Let's do a cross multiplication. 4x squared equals 20x minus 24, equivalent to the 0. 4x squared minus 20x plus 24 equals 0, divided by 4. X squared minus 5x plus 6 equals 0. Let's factorize it. You can use a general formula. X minus 3, x minus 2. So I have two x values. X equals 3 and x equals 2. As I said before, you have to do check. You have to do check. You may accept both or accept one and reject the other one. Let's start and check x equals 3, 2, 4, 2 by 3, 6, minus log base 4, 5 by 3, 15, minus 6 equals 9. So the answer will be 1, and 1 equals 1. So x equals 3 is accepted answer. Check the other one. 2 log 4 log 4, 5 by 2, 10, minus 6, 4, and the answer is 1. So x equals 2 is also an answer. So I have two answers. Let's move to number 3. They want you to write the answer to 3 significant figures. I advise you to pause the video for 3 or 4 minutes, try to solve it, and just check your steps with my steps. You try solving it? Let's do it. Log 2x plus 1 base 10 minus 2 log x minus 1 to the base 10 equals 1. Now as I said, they both should have the same base and the same coefficient. So I'm going to raise 2 to become a power. Log 2x minus 1 base 10 minus log x minus 1 over all of it square base 10 equals 1. This is plus log 2x plus 1 over x minus 1 all of it square to the base 10 equals 1. Converted to the exponential form. 2x plus 1 over x squared minus 2x plus 1 equals 10. Cross multiplication. 2x plus 1 equals 10x squared minus 20x plus 10 equal to 0. 10x squared minus 22x plus 9 equal 0. Use general formula. X equals 22 plus minus negative 22 squared minus 4 by 10 by 9 over 20. I will have two answers. X equals 11 plus root square 31 divided by 10. X equals 11 minus root square of 31 divided by 10. Now, as I said, you have to do check. And after check, which I'm going to leave it for you, you're going to accept the first answer and reject the second one. Because the first answer is the correct one, and I have to write it to 3 decimal places. So write it to 3 decimal places. Okay, so the answer will be for the first one, 1.657. I hope your answer is similar to my answer. And let's move to the last question. It's a past paper question. Question number 2I. Show that the equation log x plus 5 to the base 2 equals 5 minus log x to the base 2 can be written as a quadratic equation in x. Okay. As I said, I have more than one logarithmic term. I have to combine them to get one logarithmic term. Log x plus 5, move this one to the left side, plus log x. They both share the base, the same base, which is 2 equals 5. Combining addition is multiplication. X by x plus 5 to the base 2 equals 5. So I'm talking about x by x plus 5 equals 2 to the power 5. X squared plus 5x equals 32. X squared plus 5x minus 32 equals 0. Okay, I'm going to solve it another way comparing to the Edexcel. Edexcel students, 5 can be written as 5 log 2 to the base 2. So it will log x plus 5 to the base 2 equals 5 log 2 to the base 2 minus log x to the base 2. The students will ask me, why miss 2? Because the other terms having the base 2. Because I should have logarithmic terms sharing the same basis to be able to combine them. And I said before, log a to the base a equals 1. Log x plus 5 to the base 2 equals log 2 power 5 to the base 2 minus log x to the base 2. Combine log x plus 5 to the base 2 equals log 32 over x to the base 2. Because the both sides sharing the same logarithm, same base, I'm going to cancel out log. I'm going to say I have one logarithmic term on the left side, one logarithmic term on the right side, both one logarithmic term sharing the same base. I can cancel both. So x plus 5 equals 32 over x, cross multiplication, x squared plus 5x equals 32 x squared plus 5x minus 32 equals 0. Let's move to part double I. Part double I, talking about solve the equation. As I said, you have to solve it. Show how you solve the equation. You may use factorization. You may use general formula. In this case, I can't use factorization. I'm going to use the general formula, and you have to show it. So x equals negative 5 plus minus 5 squared minus 4 by 1 by negative 32 over 2. And I will have two answers. The first one, x equals negative 5 plus 3 root 17 over 2. The second one, negative 5 minus 3 root 17 over 2. As I said, you have to do check to choose both or one of them. And according to check, you're going to reject the second one and accept the first one. So the answer, x equals negative 5 plus 3 root 17 over 2. I hope today's class is clear, students. Please solve more questions. Go back to your math book and solve the exercises. See you next class, solving exponential equations. See you then.